Hey guys, we're going to take a look at question number 3 in our calculations involving the equilibrium constant. In question number 3, we're given the reaction that a molecule of A2 combines with a molecule of B and forms two molecules of the product C, and those two molecules of the product C will then decompose back into one molecule of B and one molecule of A2. So it's found that by adding 1.5 moles of C to the container, and that's all we add, an equilibrium is established in which 0.3 moles of B are found. So we're not given enough information to answer this question. Or are we? Let's take a look. So for question number 3, let's set up our ICE tables. So we've got A2 plus B enters into an equilibrium with two molecules of C. Okay. So let's solve for our initial concentrations. I'm going to make this table up with a double line under the equilibrium sign to keep my reactants and products sorted out. Now our initial concentration is 1.5 moles in 1 liter. So that's 1.50 moles divided by 1.0 liters. That's 1.50 molar. That's my initial concentration of C. What is my initial concentration of A and B? Well, it's 0. We didn't add any initially. Next, we're going to figure out how does this change over time? Well, you can't get less than 0, so these are going to each increase by some amount. And you can't get A and B as our product C kind of decomposes back into reactants. You can't get A and B without losing some C, so we're going to lose some. Now, they're all connected by the mole ratio, so we're going to use that change as a factor X. So for every X molecules of A2 that are formed, an equal number of B are formed. And for every mole of A2 and B that are formed, we lose 2 moles of product C. That's that mole ratio. Now, at equilibrium, or EQBM for short, the final concentration of A will be 0 plus X. The final concentration of B will be 0 plus X. And the final concentration of C will be 1.50 subtract 2X. Now, we were given an important piece of information. 0.3 moles of B were found. Therefore, X equals 0.30. So the concentration of A2 is equal to X, which is equal to 0.30 molar. The concentration of B is equal to 0.30 molar. We were just given that in the question. And the concentration of C is equal to 1.50 molar subtract 2X, which is 1.50 molar subtract 2 times 0.30 molar, which is 0.90 molar. So for question number 3a, we're done. 3b asks us to solve for KEQ. So KEQ, this is B now. So A is done. KEQ is equal to the concentration of our product C squared divided by the concentration of our reactants, the product of those two concentrations. So on the numerator, we've got 0.90 molar squared, right? For A2, we've got 0.30 molar and 0.30 molar. Those two values. If we simplify this, 0.9 times 0.9 is 0.81 molarity squared. 0.3 times 0.3 is 0.09 molarity squared, 0.090. Oh, crazy. So KEQ is equal to 9.0. And because there's molarity squared on the numerator and denominator. There is no unit in our final answer. So for B, solving for KEQ, our answer, 9.